You're listening to the Modern Mainframe, BMC's intelligent Z optimization and transformation podcast, covering the latest trends and issues on the mainframe and how BMC AIME and BMC CompuWare solutions can help you build a mainframe-inclusive DevOps toolchain. Hey everyone, welcome to the Modern Mainframe. I'm Matt Dallaire. Joining me today to discuss the refactoring of mainframe code are BMC Director of Software Consulting Tim Ceradsky, DevOps Evangelist Tony Anter, and Lead Product Manager Mark Schettenhelm. Tim, Tony, Mark, thanks for joining us today.
Glad to be here, Matt.
So, Mark, we sometimes hear about a fear of working on the mainframe, that developers don't want to work with COBOL. What's behind that? Why don't developers want to work on mainframes?
You know, it's an interesting question, and I've spoken with so many people in the last year or two about this, and it's a universal thing where people don't want to work on the mainframe, and they often phrase it as, I don't want to work with COBOL. I can't get anybody to work with COBOL. And I think we're really using the wrong term there. When we say COBOL, what it really is, they don't want to work with these mainframe applications, and the applications happen to work in COBOL. So I think that COBOL really is being the victim here because it's not a problem with the language. It's a very good language. It's very easy to learn. It's very powerful. The problem is the architecture of the mainframe applications themselves with these massive programs which are very difficult to understand, change, and test. That is the difficulty in which making mainframe development slow, not the fact that it has to be in COBOL.
Yeah, and I think this is a natural consequence of mainframe application development sort of freezing from an architectural point of view in the late 90s. Because of that, naturally people have stopped working on these platforms because it's one and the same, and a lot of people were moving to platforms that were advancing, for lack of a better term, or being more innovative on the cloud, distributed side, mobile, things like that. So I think this is a natural consequence of that freezing of application development. You're going to see people move off because, to Mark's point, COBOL is like any other language. It's just a language, and it's got a lot of cool features and functions. Anyone out there probably has 2 or 3 languages under their belt.
With that freezing, the development staying in the same language, in the same format, using the same processes, it's led to the code kind of being built upon, right? Instead of new programs coming along, we've built upon old programs, and that's made them quite large, I would assume.
Yeah, people are piling functionality on top of functionality on top of functionality in the same module, in the same place. And there's a lot of reasons for that, probably architectural reasons, development reasons that were there. I've heard Mark talk about development in the 60s, 70s, 80s, and there were legitimate technical reasons why they did things like that. But now you've compiled technical debt. The reason why people refactor their code is as you build one thing on top of the other, it starts becoming unwieldy. And you need to break it up into smaller pieces from a functionality point of view, just so you're not piling that technical debt, because someday the bill will come due. And I think that's what you're seeing now.
So, Mark, after so many years of these unspoken policies of don't touch, don't break, why are enterprises now addressing this technical debt?
Right. It's because customer needs don't stop. We really need to innovate. Any organization is really an IT organization. It's based on that. And this innovation is coming so fast. And really with the mainframe, these applications being at the core of the processing, everything eventually is going to hit it. So there's this big drive to change. And at the same time, you have people that are afraid of touching these applications because they're afraid to touch them. They don't understand them. They're difficult to work with. And so that is a really, I think, a core issue. It's the demand to change, and yet there's a fear. And we really need to find ways to break through that to give the developers the confidence to go in and make these changes. And as Tony is saying, refactor them so that they can respond quicker to meet those demands.
And another part of it is that with these large programs and with the way development is done in the mainframe, the large program has to entirely be checked out, correct? So they can't work on one part of it, and there can't be concurrent work on different parts of the program.
Yeah, that's really the core issue, and is that Tony kind of touched on that historically it's been, oh, I have to go add something. I'll just add it to that program. At that point, they should have made a smaller program and should have done more. But maybe because they didn't have source control back in the 70s, they were afraid of calls taking more memory and processing. They didn't do it, so they just keep adding and adding more. Now what happens is I need to make a 2-line change in a program. I have to check out the entire program, go through the entire program and understand it all to find my logic, make my change, and then I have to compile the whole program, and then I have to go in and try to test it and discern that from these inputs and that outputs, it somehow hit my section and it probably tested my logic. And that gets multiplied when you have, because all the logic's in the one program, someone else is not trying to do it. And now with 2-week sprints, we're much more getting concurrent work. And then you got 2 people working with the same program, or 3. It gets complex. And that's why, and as Tony said, the other architectures are much more into small services. You don't have any of those issues at all.
Yeah, I mean, think about it from a logical level, right? You can now take a small piece of functionality and make an adjustment to that functionality without affecting everything else. So your deployment gets smaller, your impact gets smaller, your coding, what you have to check out and what you have to code gets smaller. It just makes everything easier to work with. And that's the whole reason why you've seen a lot of platforms and applications look at refactoring their code and actually breaking these things down. Being a 12-factor app like they do in the cloud, there's a lot of benefits to that. And that's why they went down that path.
So, Mark, we have a new solution out called BMC AMI DevX Code Insights. Can you maybe talk a little bit about what it does and why it was developed?
Right. What it is it's a relaunch, really, a rebranding of what we've had before with the analysis in our code analysis product. So we've built on the ability to do the structure charts and the data flow and all that, but added this new extract capability. Because we've talked to customers with these issues of the large programs and the difficulties they have, some have taken the difficult manual step of doing it. These are very large projects that most organizations just aren't willing to do. So we came up with a way to analyze your program, come up with candidate paragraphs to split off, and you can search for like business logic in them or by complexity, and then it automatically will extract those, remove that code from your main program, create a new sub-program that's callable, and have all the variables in there, and it will do the calling, passing the variables, all that, so you have 2 separate compilable programs going forward. So it helps you with the analysis, automates the splitting it off, and we hope it's a way that sites can now start to tackle this technical debt, break apart things so that they can really start to use faster development methods and get things out to their end users faster and come up with more reusable code.
Including concurrent development, right?
Yes. Oh, yeah. It will drastically speed concurrent development.
So, Tim, when you talk to customers and when you work with them on their pain points, are you seeing them try to refactor code manually? And what are the challenges that they're finding with that approach?
Sure. The hard part about manually refactoring is you have a lot of complexity that you have to digest and understand before you can map out a strategy to do it that way. And you're really putting it a lot of it on the developer's head to have to keep track of all the details. What's the logic flow look like? How many data fields am I keeping track of? How do you pass that information from one chunk to another, and so on? What really helps in what we're doing with the tools is we're giving the developer the ability to automatically create logic charts, to automatically structure chart the program out so you can logically snag chunks of that program that are either complex or handle a lot of data, etc., and begin to intelligently break those pieces apart, but also giving it the scaffolding to ensure that you're not breaking things as you go. And empowering them to do those things, it just gives them a framework, a structure to do this refactoring, so you're not having to do everything by hand. Because let's face it, when you see a bunch of people, you get 100 people trying to tackle something, if you give them all the do it all by hand, you get 101 different ways of doing it.
Right.
Yeah, and I think that's really important because people might say it's a good idea and they've thought about it, but trying to do it manually, it's, as we said, it's already hard to understand these programs and work with them, but then to break them apart, some organizations have taken that step to break them apart, but having a tool to go in and understand it and do it makes it all a lot easier.
And look at this from the point of view of someone who hasn't spent decades in this code base. Right? Because you've been piling things on top of things on top of things in this code base for 30 years. Now, all of a sudden, you've got a guy who's a couple, 3, 4, 5 years in, and now they're being asked to sort of trace through this spaghetti code. Doing that manually, that just adds to your level of difficulty.
And adds to the time taken.
Yeah, absolutely.
To add one final point to that, I'll go back to kind of the fact that everybody would do it a little bit differently. One of the real benefits of using Code Insights here is that we're breaking out these pieces of code in a reusable, shared way. So it's going to identify the code that everybody needs to use, pull that out into chunks, and start to build up that library of shared services, shared logic that we can take advantage of, and you're really creating a standardized way of thinking about the code that is shared amongst all the developers, and it provides that scaffolding rather than just expecting them to do it all on their own. And so that really starts to foster a sense of collaboration and velocity that you can't get any other way. You can't maneuver this way without providing that scaffolding and giving everybody the chance to work together.
I like to watch a lot of these Gordon Ramsay cooking videos, cooking shows, whatever. And when he's breaking down a large piece of meat, especially fish, as he's doing this, he has a saying. He says, "Let the knife do the work." And he sort of slides his knife through things, right? And I think that applies here. I think to sort of bring that analogy back to where we're at, I think something like Code Insights, it gives a developer the capability for letting the knife do the work. The developer still needs to understand what he wants and what he wants to pull out and how he wants to refactor this code. But then a system like Code Insights gives them the tooling or the capability necessary to be able to break that up and very easily pull these things apart, right? It goes back to, like I said, let the knife do the work.
And so we've talked a little bit about different sites doing this and reasons why they would want to. How do they decide when it's time to start the effort? And what factors should they consider before committing to such a project? Mark, I'll start with you.
Sure. I think an excellent place to start is with our Z Advisor, because what you want to look for is code that you're changing frequently. Because if you're not changing it too often, you don't really get the benefits. So code that you're changing frequently, and then code that has multiple developers working on it. And then you can start to look at the size of it and break it apart. but that will tell you where you're spending your time too, not only changing frequently, but wow, we're changing it and this is taking us twice as long to work with this program as opposed to another program. You'll be able to come up with some metrics that'll help you easily identify your candidates and really build that business case to go in and use the tool to go in and break apart these programs and get the benefits. And then afterwards, measure the benefits, which will help you in justifying doing this for other programs.
Tim, why do you think this is an important step for organizations to take right now?
Well, I'll tell you, the interesting thing, having been out talking to customers in this space almost 10 years now on almost this very topic and others, I spoke at a conference a year or two ago in New York, and we were talking about the importance of grappling with your technical debt, addressing the need to drive innovation in the mainframe space. And I had a gentleman stood up out of maybe a couple hundred people in the room, and he was passionate. And he said, don't you understand? We can't get into this mainframe code. We didn't write it. We don't really understand it. It's very dense. These programs are huge, and it's just too critical. Well, they've been running basically unchanged for 20 years. My boss is breathing down my throat, trying to get me to make changes. And I don't know what to do because we can't go forward from where we're at, but we can't afford to stop what we're doing either. And I looked at him and I asked, well, let me ask you a simple question. Of the code that you have, how are you going to get a better understanding of it using what you're doing now? And he's like, we can't. I don't have the time in the day. I'm like, well, let us show you a better way. Let us show you a way that you can actually see how this code is constructed and start to break it down and understand what it's about. And throughout the rest of that session, you could see the light bulb come on. It's not that you can't do it. It's that you haven't been given the tools and the encouragement to tackle it and taking the first step on the journey. And that's all this is about. You're never done with the journey, but it's a matter of let's get the right set of tools in people's hands so they can make that journey.
Right.
And I mean, let's be honest, right? This is necessary to move to the next level, right? No, mainframe DevOps is here. People are automating their mainframe loads. They're automating their mainframe app dev capabilities. But the reality of it is that if you want to get to that next level, if you want to really start doing things like, adding in unit testing at the lowest level, start adding in canary deployments and blue-green deployments, a lot of this advanced functionality to be a more mature DevOps organization, you're going to need to break these down. You cannot do a lot of that with these giant monolithic programs. You're going to have to separate them out into smaller units by functionality and go down the same path that distributed applications did when they moved from traditional VMs to the cloud.
Right. And the time is really now to do this. We're at a very good point to really address these. We've been worried for the last several years about those that know the application retiring. Now they pretty much have. We've already passed the torch. That has already occurred. Either they're gone or they're going to be gone soon. So now we're having people come in and looking at the mainframe with a fresh perspective, and they don't really like what they see. They want to work with it, but what we have to do is get the right architecture to make them, to make it easier for them to work. So I think some of the things that might have held you back in the past are gone. We're at a moment where you can do it, and as Tim and Tony have said, it's now the time where you have to do it. So everything is coming together to make it the time is now.
I think that's an excellent point to leave off on. Mark, Tony, Tim, thanks again for taking the time to discuss this important issue today.
Thank you, Matt.
As always, Matt, it's a pleasure.
Thanks also to our listeners. I'll include some links for further information in the show notes, so be sure to check those out. And we'll talk to you next time on The Modern Mainframe. Take care.
You're listening to the Modern Mainframe, BMC's intelligent Z optimization and transformation podcast, covering the latest trends and issues on the mainframe and how BMC AIME and BMC Compuware Solutions can help you build a mainframe-inclusive DevOps toolchain.